Hello, good morning everyone. Am I audible?
Yes, ma'am. Yes, ma'am.
Hello.
Yes, ma'am.
Okay. So what we have seen in the last lecture, we have started with the definition of a vector field, right? First, in last two lectures, we have seen what is a differential geometry, what is a tangent vector, the two properties of a tangent vector, vector addition and scalar multiplication. With the help of these two, we have proved that it is a vector space. Next, we have started with a vector field. What is a vector field? It is a collection of all the tangent vector once at every point. At every point of P, you have to go. And what you have to do, you have to find out one tangent vector. कुठलाही point ला जाओ P. At any point P, of a E3 space, you have to find out one tangent vector. Is it okay? So this is what your vector field. And what is TP of E3? It is nothing but tangent space. At any point P of E3 space, you can find out many number of a tangent. That means they are intersecting because their point of application is same, but the vector parts are different. Okay. And after that, we have seen what are the natural vector field. What are natural vector field? That is U1, U2 and U3. Natural frame fields. Okay. That means all the vectors are going in the single direction, either in X, Y or Z direction. For Y, it is all the vectors are going in this direction. And for Z, all the vectors are going in the Z direction. Okay, and after that, one theorem we have seen, that is any vector field V can be written as a linear combination of the natural frame fields. Okay, we have proved this theorem with the help of a vector field V applied at a point P. It will be converted to one tangent vector. पूरे vector field में से हमें सिर्फ एक point select करना है, right? If you go to a point, it will be a tangent vector. Okay, there is some difference in this tangent vector and V of P. This is in the vector field and this is arbitrary one. It is not necessary that it has a specific one vector field. Okay. So for that one, we have proved this with the help of V1 of P. Next is V2 of P. Simply these are nothing but your coordinates of that point, right? And with the help of this one, we have proved the result. And also I have given you that you have to take any vector x, y, z, or you can take any vector, say it is 3, 7, -1. So you have to just write down this vector in the form of a 0, 0, 1, 1, 0, 0, and sorry, 0, 0, it's 1, 0, 0 firstly, then it is 0, 1, 0, then 0, 0, 1. So any vector you have to just write down in the linear combination of a basis vector. Okay, this is what our theorem want to tell us, that any vector can be written as a linear combination of these three vectors. Okay, and the next very important thing which we have seen, how to shift the origin. If origin is 0, then if suppose I have some another origin, I have shifted this to P1, P2, P3, the point P with the coordinate P1, P2, P3. So how to find out each elements? What we have to do? This is what 1 plus P1. The next two coordinates are same. And for Y, it is P1 as it is, P3 as it is. There is change in Y, that is 1 plus P2. Okay? Any doubt up to this one?
No, ma'am. No, ma'am.
If not, let us go for the example that I have told you. In the next lecture we will see the example that so that's why let us go for the example of this one. What is given to us? V is equal to, yes, everyone should write down this example. V is equal to 2 minus 1 5, W is equal to 0 1 7. Okay, and what is given to us? P is any point from E3 space. Then what is 5EP minus 3WP? You have to write down 5EP plus 3WP as a linear combination of U1P, U2P, u3p. Okay, are you getting what is the example? Yes, can anyone explain me what is given in the example? आहेत का जागे सगळे सकाळी? हॅलो, हू हॅज जॉईन सो लास्ट? आत्ता कोणी जॉईन केलं? नाव सांगा. येस. Okay, just tell me what you get from this example. Have you understood what is given in the example and what you have to do? Hello?
Hello, ma'am. Screen is not visible.
Okay, now you can tell V is one vector, W is one vector. What you have to do? 5VP minus 3WP, you have to write this in the linear combination of U1, U2, U3. That means simply we have to apply the theorem whatever we have seen. But the theorem was related to vector field, but actually this theorem we have proved with the help of a tangent vector itself. Okay? Those who are attended the lecture concentrately, you can imagine that what we have done in the last lecture, whole vector field applied on a point म्हणजे कुठे जाणार आहे तो पूर्ण वेक्टर फील्ड मधून एक पॉइंटला गेल्यावर तिथे काय भेटणार आहे आपल्याला एक टँजंट वेक्टर. So the last theorem we have proved with the help of a tangent vector itself. Okay, so what we have to do in this lecture also, in this lecture we have to study the example whatever based on our theorem. Okay, two vectors are given, you have to write down the new vector. Okay, now just my question is what 5VP minus 3WP हे पण एक वेक्टर होणार आहे का? हॅलो,
Yes, ma'am.
okay, how this is so, can anyone explain me?
V आणि W टू वेक्टर्स त्या लिनियर कॉम्बिनेशन मध्ये पुट केल्यावर मग नंतर त्याचे ऍडिशन वगैरे करून मग मॅडम एक वेक्टर येतं ना.
How is it possible? In the last lecture we have seen the two properties, no? What are the two properties we have seen? Vp plus Wp is nothing but V plus W at a point P for tangent vector. Next we have seen AVP is equals to AVP. Okay, with the help of these two properties, scalar multiplication and vector addition. इथे पण तेच आहे ना, scalar are 5, 3. And instead of addition you can write this as plus of minus, correct? So you can say that with the help of these two properties which we have seen in the last lecture, that with the help of vector addition and scalar multiplication defined on the TP of E3, right? What is your TP of E3? It is a tangent space. T is a notation for the tangent and P is a point in E3 space, and completely we call it is a tangent space. And this tangent space, the name itself, it suggests that with the help of these two properties it satisfies all the properties of a being a vector space. समझते हैं?
Yes, ma'am.
Yes, ma'am.
Okay, so what you can answer for this one? 5vp minus 3wp will be again a tangent vector. हे कशावरून सांगू शकतो आपण? Because of the two properties which we have seen in the last lecture. Tangent vector space. Instead of saying tangent vector space, it is called simply tangent space. Okay, this is what is scalar and this is a vector addition, and hence with the help of this one we can prove that the resultant vector will be again a tangent vector in the same tangent space. Okay, this is what a tangent space. At a simply point P we have to define many number of a tangent. Okay, so what is our aim to write down now? We have to write down 5vp minus 3wp as a linear combination of u1, u2 and u3. Okay. So for that, first we will evaluate what is 5p. What is vector v we are provided is 2 minus 1 5. I hope everyone is writing this one. P. The next vector w is given to us as 0 1 7 at a point P. Okay, written this one.
Yes, ma'am.
5 minus 5, 5. This is 2, no? Okay. Okay, if you have written this, just tell me what is the
10
result.
minus 4.
10 minus 8.
Okay, 10 minus 5, and this is what? 25 at a point P minus 3 into 0, 3. This is 21 at a point P. Okay. So 10 minus 0 is 10, minus 5 minus 3 will be minus 8, 25 minus 21. What is the resultant? 4 at a point P. But what is our question? We have to write down this 5 Vp minus 3 Wp is equal to, in the linear combination of the 3 vector u1, u2, u3 at a point P. Okay, so how to do that? In the very similar way which we have done for the theorem with. So what you have to
10
do?
into 100
Yes.
minus 8 into 010 plus 4 into 001.
Okay. Plus you can have this is as minus 8 0 1 0 at a point P, plus next one is 4 outside 0 0 1 at a point P. So we can write what is this is 1 0 0 at point P, 0 1 0 at a point P, 0 0 1. So this is what u1 at P minus 8 u2 at P plus 4 times u3 at a point P. Now this we have written in the linear combination of u1, u2 and u3. Understood this example?
Yes, ma'am.
Any doubt for this example you can ask. Okay, let me give you this one more example. What you have to do? V is equals to 1 vector minus 1 0 1, and w is another vector 2 0 3. Okay, there are two vectors v and w. Again, what you have to do? 2vp plus 3 wp. You have to write down this as a linear combination of u1, u2 and u3 at a point P. And P is what? P is arbitrary point from E3 space. Okay, if you understood this example and if you have written that example, you can do this. Okay, try to do this and tell me the answer.
Minus 4 u1 of p plus 0 u2 of p plus 11 u3 of p.
Anyone else, have you solved it?
Yes, ma'am. 4 U1 at P, 11 U3 of P.
what the answer is from Rutuja? What you answered?
Yes, ma'am. 4u1 of p येते.
Okay. Yes. Anyone else? किती जण आहेत मीटिंग मध्ये?
Yes, ma'am. आले.
33, including me it is 34. Actually it is 32 students only. I hope everyone has solved it. At least the example which I have solved, you have written it. Okay. So let us go for the vector field example now. Okay. Let V is equal to, we have been provided with the two vector fields. Let V and W be the vector fields. V is equal to xu1 plus u3 and W is equals to 2x square u1 plus y u2 plus z u3 are the two vector fields. These are two vector fields. Compute the vector field. Compute the vector field xw minus x square v. Okay, we have to find out what is the new vector field. This one, xw minus x square v. Find its value at p is equal to -1, 0 and 3. Okay. What is the question? We have been provided with the two vector field p and w. What is our aim to find out? What is a vector field xw minus x square v? Right? What are these x and x square? These are real valued function. Those who remember in the last lecture, we have seen two vector additions and one vector addition and scalar multiplication related to the vector field. V and W evaluated at point P. Next one, F V at a point P. How to write down FV at a point P? F of P and whole vector field evaluated at a point P. पूरे वेक्टर फील्ड को एक सिंगल पॉइंट पे जाने के बाद क्या मिलेगा आपको वहां पे? एक tangent वेक्टर, राइट? Okay. Have you understood what is given and what is our aim to prove?
Yes, ma'am.
Okay, just can anyone explain me what is given and what we have to do? See, as we are in the MSc, we should have a discussion sessions. Again, this is what the last stage where you are going to be study like a student. Otherwise, in the next one, if you go, you have to study like if you go for PhD, you are PhD student, or we can call it as a research scholar. And if you go for B.Ed, no doubt that is not a student category. You just uh, go for how to teach, right? Yes, we should have a healthy discussion sessions. Okay, let us go for the solution. What you have to do? First, you have to find out the value of xw minus x square v. Okay, w and v both vector field we are knowing. I hope everyone writing the examples. X value of a w, that is a vector field w, is given as 2x square u1 plus y u2 plus z u3 minus x square, value of a b is x u1 plus u3. लिहिले होते का तुम्ही w आणि v vector fields?
Yes, ma'am.
Yes,
Okay.
ma'am.
If you have written, just tell me the answer with the help of separations. क्या करना है आपको? u1 के कोएफिशिएंट अलग निकालने हैं, u2 के एंड u3 के. Okay, calculate
X
it and
cube
help.
u1, x cube u1 plus xy
No,
u2
do the
plus
calculation completely. यहाँ पे भी u1 है, यहाँ पे भी u1 है, दोनों का कॉम्बिनेशन लेना है आपको. राइट, पहले ये इवेलुएट करो माइनस द कोएफिशिएंट्स ऑफ u1, और यहाँ पे u2 है, यहाँ पे u2 नहीं है. ओके, सो यू शुड इवेलुएट वेरी केयरफुली. I am asking the answer of whole calculations after doing that minus x square b.
X cube x cube u1 plus x by plus z minus x square into 3.
Your voice is not clear. X cube u1. Next
u1
is
plus
plus
xy
xy
u2
y2
u2
acha x by u2. Okay. What about the third one?
z
plus
minus x
x
square into u3.
Simply z minus x square.
x into bracket z minus x u3.
Xz minus x square. No.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Coefficient of u3. Okay. Just check it. Coefficient of u1 is x square. Sorry. Coefficient of u1 is x cube. Coefficient of u2 is xy. Coefficient of u3 is xz minus x square.
Yes, ma'am.
Yes, ma'am.
Yes, everyone got the same answer?
Yes, ma'am.
लिहितायत सगळेजण?
Yes.
Yes, ma'am.
Okay. What is the next question now? We have to evaluate the value of this one at a point P. Okay. What is the point P given to us? लिहिलेत का?
-103.
-1.
-1 0.
Okay. So what is the value of this one? We have obtained this as x of P cube u1 at a point P. Correct? Plus next we have found x at a point P, y at a point P, and u2 of P. Plus the next one we have obtained is x at a point P into z at a point P minus x at a point P, it's a square, and this is what the coefficient of u3 of P. Now what you have to do, you have to find out the value at P is equals to -103. Okay, value of x is -1. So what is a -1 cube?
-1.
Minus
Yes, -1. And what is the value of y? 0. This is u2p. Plus next value of x is -1 into z. Z of p is 3 minus -1, it's a square, u3. Okay. So just you have to put up wherever you are having the values of x, y, z. That is -1 u1 at p plus u2 का कोएफिशिएंट क्या आ जाएगा? 0.
-4.
Okay, this is what +1 -3 -1, it is -4 u3 at a point p. So in general, what we can write, the value of this vector field at a point -103. That's why I told you the whole vector field, if you are going to evaluate at a single point, what will be the value of that vector field at a single point is equal to -1, 0, -4. But you have to write down this here. At a point P is equal to -1, 0, 3. Because अगर आप पॉइंट P चेंज करोगे तो ऑब्वियसली ये वैल्यूज चेंज होंगे, right?
Yes, ma'am.
yes, ma'am.
Whole the vector field, if you are going to evaluate at a single point, no doubt the value of this whole vector field is changing. Now again the same question, whether if V and W both are vector field, right? Both are vector field now. whether their result linear combination is also a vector field?
Yes, ma'am.
Why this is so? Because of these vector addition and scalar multiplication which we have defined on a vector field. ये scalar है ना, real valued function. Value of a real valued function evaluated at a point p, f of p. यहाँ पे भी वैसे ही हुआ ना, function x cube evaluated at a point p, value of this xz evaluated at a point p. Correct? So these are real valued function evaluated at a point p. So with the help of vector addition and scalar multiplication, we can say that xw minus x square v is again a vector field, and value of that at a point P is minus 1, 0, minus 4. Okay, now let us go for one more example. We have v is equal to one vector field, v is equals to y square u1 minus x square u3, w is equal to x square u1 minus z u3, y square u1 minus x square u3, x square u1 minus z u2. Find the function f and g such that, find the functions f and g such that, find the function f and g such that fv plus gw can be expressed as, in terms of u2 and u3 only. Okay, fv plus gw should be able to express in the form of a u2 and u3 only. Try to understand this and tell me the answer. Yes, समजला काय दिला एक्झाम्पल मध्ये?
Yes, ma'am.
Yes, can you explain me how the function f and g we have to find out in such a way that fv plus gw can be expressed in terms of u2 and u3 only?
F must be x square and g must be minus y square.
F must be?
X square
Acha.
and g must be minus y square.
Okay, good one. You tried, it is good one. Let us solve it. Okay, what is our aim to do? fv plus gw is equal to, what you have to do? fv plus gw is equal to, we have to write this in the form of u2 and u3 only. मतलब u1 का coefficient 0 है ना, so just
Yes, ma'am.
okay. What is your v? V is y square u1 minus x square u3 plus g. What is the value of w? We have provided x square u1 minus z u2. Okay, let us evaluate. What we get, we have to just separate the coefficient. Fy square plus gx square. So it is coefficient of u1, right? Now let us collect the coefficient of u2. What is the coefficient of u2?
minus fx square
Sorry, it is not minus fx,
minus gz u2
minus gz u2. यहाँ पे u3 है ना. Okay, what is the coefficient of u3?
minus fx square.
minus fx square. This is coefficient of u3. Okay, what is given to us? Fv plus Gw can be written in the linear combination of u2 and u3 only. So what must be the question? That is, your coefficient of u1 should be equal to 0. Barobar?
Yes, ma'am.
Yes, ma'am.
So that's why what you have to do, fy square plus gx square should be equal to 0. Right? The coefficient of u1 should be equal to 0. And hence we can say that fy square is equal to minus gx square. So actually this is what a single equation in two variable. One equation in two variable. Can anyone tell me which solution we can get a single equation in two variable? दोन इक्वेशन दोन व्हेरिएबल असेल तर आपण सांगू शकतो ना सोल्युशन. But if we have only single equation in two variable, what are the two variables? X and y. Because we want to find out a function f and g in such a way that the fv plus gw should be in the linear combination of u2 u3 only. So that's why we have made the coefficient of u1 should be 0. Okay, single equation in two variable.
No solution. Infinite.
Infinitely many solution. Why this is so? Because here you can observe this equation. If I change the value of g का value मैं कुछ भी assume कर सकते हैं ना. Suppose I have assumed the value of g as x. There will be some value of f corresponding to that. If I assume the value of g as y, if I assume the value of g as say z square, corresponding f चे values change होणार है. Right? So that
Yes,
is
ma'am.
what the many number of solution we can find out, and hence it is called a infinitely many solutions. Or rather, we can say that f is equals to minus x square into h, and g is equals to what will be the value of g? Y square
Y
into
square.
some h. What is that h? That is what we want to assume any value, right? यहाँ पे जैसे हमने value of g change करने के बाद value of f भी change होगा. So that's why you can say that this is a having infinitely many solution, and that's why we have selected f as minus x square h and g is equal to y square h, where h is a real valued function. यहाँ पे जैसे हमने real valued function define किए वैसे ना, you can say have the xy also, then corresponding value of f will be changing. So there are infinitely many solutions, right? And hence we can say that the value of f is minus x square into some h, value of g is y square into h, and hence the result. Okay, any doubt for this example?
No, ma'am.
Okay, so let me go for the next one, that is directional derivative. Yes, have you worked on this homework? I have told you, no, to find out why there is need to introduce the ordinary derivative, then partial derivative, then directional derivative. तीनों भी हो गया है ना आपको? Somewhere in the BSc you have studied ordinary as well as partial derivative. In the MSc first year, first semester, uh, रियल एनालिसिस पेपर वन, रियल एनालिसिस के पेपर में कहीं आई थिंक इट इज थर्ड और फोर्थ चैप्टर इन विच वी हैव अ कंसेप्ट ऑफ अ डायरेक्शनल डेरिवेटिव. बरोबर?
Yes, ma'am.
Okay. So for the concept of a directional derivative, let us start with the ordinary derivative. What we do in the ordinary derivative, we find the slope of a tangent. Okay. Suppose this is what a function f, then value of a slope of a tangent, or we can say rate of change, is nothing but your ordinary derivative. Correct? And how it is a slope of tangent and all, that is a basic part. I hope you have studied this in your vacation, जहाँ पे mostly you can study this on a Khan Academy, where you can download this app. Even you can study this on NPTEL lectures. बेसिक लेक्चर करना है आपको, बहुत ज़्यादा डिटेल में नहीं जाना है. यू कैन गो फॉर द BSc lectures, you can go for their 12th standard lectures. Khan Academy में तो directly आप type करोगे कि why the derivative is a slope of tangent or rate of change, they can give you in detail video lecture इसे. Okay, even you can go for NPTEL courses, so you can observe there those basic ideas why the derivative is a slope of tangent and why the derivative is a rate of change. Okay, the next one, the concept of a partial derivative comes. यहाँ पे डेरिवेटिव के लिए हम लोग क्या कर सकते थे, y is equal to some f of x or z is equal to some f of x. That means variable x is a independent variable, or you can have x is equal to some f of y, in which y is independent, x is dependent. Okay, single independent variable होगा तो हम ordinary derivative, right? Even in the ordinary derivative also we have a classifications, right? In the partial derivative, what is the concept of a partial derivative? Suppose we have more than one independent variable. Suppose it is of the form z is equal to f of xy. Then how to find out the derivative? It was somewhat difficult, so that's why the concept of a partial derivative comes. Okay, and partial derivative, for derivative we know that derivative implies continuity, the reverse is not possible, but partial derivative does not implies that your function is continuous. I hope you have a counter example for this one, you have studied in the paper of real analysis. Okay, partial derivative does not imply the continuity, this is what the drawback of this one. And how to find out the partial derivative? What we do for the partial derivative, we keep the one function f as it is and we find the derivative of other, plus we keep g as it is, then we find the derivative of another one. Correct? So at a time we are only finding one derivative itself. ऑर्डिनरी में भी यही करते थे ना हम लोग, एट अ टाइम एक ही फंक्शन का डेरिवेटिव इवैल्यूएट करते. But here also we are doing the same thing. We are keeping f as it is. We are finding the derivative of other plus g as it is. Then derivative of f. Product rule. पता है सबको?
Yes, ma'am.
Okay. So in the partial derivative, we are not doing very extra efforts. What we are doing, we are simply keeping one function as it is. Then we are finding the derivative of other one. Correct? So the partial derivative, the concept of a partial derivative, whatever we have studied, just like in the ordinary derivative, what we have done is ordinary derivative is a slope of a tangent. Correct? ये हमने in detail description में देखा है in the somewhere in 11th or 12th standard why it is a slope of tangent. Can anyone tell me what is a geometric interpretation of a partial derivative? Yes, Kaya says geometric interpretation. Okay, just tell me what is a partial derivative or how partial derivative is applied for this function. And then we'll come for the geometric interpretation. कसं काढणार आहेत partial derivative? Okay, let me give you a very easy one. X square plus y square plus z square is equal to 1. Okay, now how you are going to find out the partial derivative? Yes, no one from you people are knowing how to find out the partial derivative if the function is like this. You can find out the partial derivative. No? कैसे find out करना है?
Ma'am, partial derivative of a function of several variable is its a derivative with respect to one of those variable and others are constant.
तेच सांगा ना कसं लिहिणार आहे. That is known to us. No doubt.
When
It is
we
correct.
find out with respect to x, we give 2x plus 2y dy by dx plus 2z dy by dz by dx is equal to 0.
Is equal to 0. 2x. Can you repeat once again, please?
2x plus 2y into dy by dx plus 2z dz by dx is equal to 0.
Okay. Yes, anyone else can make the efforts for this function z is equal to f of x. How to do the partial derivatives? Application काय असतो partial derivativeचा? कुठे apply करतो? No doubt we have a applicationचा coordinate derivative which is used in the physics for the finding velocity, acceleration. But what are the applications of your partial derivative? Okay, I
Ma'am,
haven't
2x
asked you. Yes,
2x plus 2z into dz by dx.
dz by dx. Okay. Can you explain how you found this?
Derivative of x square into dx by dx plus 2y into dy by dx plus 2z into dz by dx is equals to 0.
That means you are evaluating the derivative with respect to x. Is it okay?
Yes, ma'am.
Okay. Yes, now can you give me whether there is a geometric interpretation of a partial derivative, how it looks like?
मॅम 3D मध्ये असतं एवढं माहिती आणि ते प्लेन असतं आणि एखादं पॉइंट आपण एक्स वाय वर घेतलं आणि ते पॉइंट त्या प्लेनवर जॉईन केलं आणि तिथं टँजंट काढलं त्या प्लेनवर
Hmm.
हाफ हाफच माहिती मॅडम तेवढं लक्षात नाही.
Okay. So what you have to do, z is equal to f of xy means what it is? A function which is defined in a 3D space. That means it will be one object in a 3D space. So if you want to find out the partial derivative means what? Slope of tangent होता है ना अपना ordinary derivative. But what is there in the partial derivative? अगर आप slope of tangent find out करोगे तो कैसे find out करोगे? Just like in this example itself, x square plus y square plus z square. Right? This is a function of three variable ना क्या है ये? Sphere है ना? Sphere center at origin, radius is 1. Okay, so it is one 3D object. So we have to find out the slope of a tangent in this one. That is what your partial derivative, no? Partial derivative में हम लोग क्या करते हैं? If suppose I am finding the derivative in the x direction, because every time you come across the thing that whenever you are finding the derivative first, we are finding in the x direction keeping y and z constant. बरोबर?
Yes, ma'am.
If I keep y and z constant and in the x direction, what I will get? In the very similar way, if I am finding the derivative in the y direction, if suppose I am finding the derivative in the y direction, right? At that time, I keep x and z as a constant. What do you mean by that one? क्या मीनिंग क्या होता है? Yes, everyone agree with this, no? You are finding the partial derivative in the x direction. At that time, y and z are constant. Assume करतो ना आपण असं. हो तर म्हणा, नाही तर म्हणा. Hello. Hello, am I audible to everyone?
Yes, ma'am.
Okay, do one homework. You have to find out the interpretation of a partial derivative. Because every time what you do, finding a derivative in the x direction, keeping y and z constant. मीनिंग क्या है? y z को कांस्टेंट ही ट्रीट करना है तो फिर पार्शियल डेरिवेटिव क्यों इवेलुएट किया हमने? राइट नो? ये सब तो हम ऑर्डिनरी में भी कर रहे थे ना. सेकेंड में क्या करते हैं? y and next one, finding a partial derivative with respect to y, we are keeping x and z as constant. Right? Just go for in detail of partial derivative, then we will come back to the directional derivative. Because if you know the partial derivative, then only I can explain you what is a directional derivative. Correct, no? This is what the today's homework for you people. You have to find out the geometric interpretation of a partial derivative, why we are doing that. Okay.